For section 7, we're going to be talking about solving radical equations. So all of these are going to still have a root of some sort, whether it's a square root or cube root or something like that. And we're going to solve the equation now, which means that there's going to be an equal sign involved. And we're going to have to work to get the variable by itself. So a simple radical expression that we might work with would look like this. The square root of x equals 4. Which if we just kind of think about that, if you're trying to square root a number and get 4, x would be equal to 16 for this problem. But we're going to have other things underneath the radical sign with your variable. At times, like you'll have the x's being added or subtracted to another number, and then that's all underneath the radical sign, and you still have to solve for the x. In order to solve radical equations, if it's just a regular square root, you start by squaring both sides of the equation. That way it gets rid of the square root sign, but then you'll also have to make sure that you square the other side too, whatever's on the other side of the equal sign, because it's the same as solving a regular equation. Whatever you do to one side, you have to do to the other so that it stays balanced. So first thing you're going to do is square both sides, or raise it to the third power or to the fourth power, whatever the root might be. Then you should get rid of the radical sign, and then it should look more like a regular equation, where you guys just use like your basic algebra to solve it. So you add or subtract first and then multiply or divide if needed to. So starting with this first one, it says the square root of x equals 9. Since it's a regular square root, we're going to square both sides of our equation. So we're going to square the left side and we're going to square the right side. When you square something underneath the square root, those two things undo each other. And so that's how we get x to just come out and there's no more radical sign. On the right side here, we have to also square 9. So we have to take 9 times 9, which would be 81. Okay, so x equals 81. And that should make sense because if you guys were to square root 81, you would get 9 to come out. So we're going to do the same thing for 2. Just notice that they have x minus 9 underneath the radical sign. But it's still a regular square root. So we're going to square both sides. The same kind of thing applies here. On the left side, that radical sign and the exponent of 2 are going to cancel each other out. And we're left with x minus 9. Equals, then on the other side we have 5 squared, which would be 25. Okay, so we got rid of the square root. Now we can solve this by adding 9 over. So we're going to get x equals 34. Now for number 3 here, I have square roots on both sides of the equal sign. I'm still going to square both sides, and when I do that, it's going to get rid of the radical signs on both parts here, on either side of that equal sign. So we're going to square the left side, and we're going to square the right side. So then 4x plus 12 is going to come down, and then equals your 6x is also going to come down. What would you guys do here to solve this one?
Subtract 4x.
Yep, subtract 4x. Okay, so I'm going to bring it over here. So I have 12 equals 2x, because 6x minus 4x would be 2x. Now what do I do? Divide by 2. So x is going to equal 6. Now you could always take these answers that you're finding and plug them back into the problem, and it should balance out on both sides. Like if I do 6 times 6, like if I plug in x, that would be the square root of 36, which is a 6. So my right side would become a 6. Over here, 4 times 6 plus 12 would also be the square root of 36, because it'd be 24 plus 12. So then you're still going to get a 6 on that side as well. So you can always go back and check your answer by plugging it into the problem and evaluating, and it should equal on both sides there in order for you to know that you did it right. Okay, I want you guys to try number 4. So you should have started by squaring both sides. So on the left side, 2x plus 4 comes down. What's 4 squared? 16. Okay, then we subtract 4. So it's going to say 2x equals 12. Divide by 2. We get x equals 6 for this one, as just like number 3. Okay, let's take a look at number 5 on the bottom of that page. So we have the square root of 35x, and then we have 5 times the square root of x plus 2. I'm still going to start by squaring both sides to get rid of those radical signs. Now on the left side, just 35x is going to come down. On the right side, though, you have to be careful because you're squaring the piece that's underneath the radical sign, but you're also squaring the 5. So think about this 2 as being like distributed to each of those pieces. So 5 squared is going to be 25. And then you're going to have that x plus 2 come out as well. So I'm putting that in parentheses because then what I need to do is distribute it. So I need to take 25 times x and times the 2. Like that. So I'm going to have 35x equals 25x plus 50. Okay, if I subtract 25x from 35x, that's going to just leave me with a 10x. So I have 10x equals 50. So what is x going to equal for this one? 5. All right, let's go to the back side here. So for number 6, we still have a regular radical sign on the left side, which means that we still need to square it. Okay, so we got to square the left side and we have to square the right side. Now on the right side, because it's x minus 2, it's a quantity like that, you're going to have to take x minus 2 times itself. So x minus 2 times x minus 2. That means that you're going to have to FOIL on that side of the equal sign. Over here on the left side, we can go ahead and just write x plus 18 because the square root and the square cancel. Now over here, I'm taking x minus 2 times x minus 2. So I'm FOILing it now. So remember, that's when you do your first terms, which would be x times x, which is x squared. Your outside terms, so the first x and that last negative 2. So that's minus 2x. Inside terms would be another negative 2x. And last terms would be negative 2 times negative 2, which is positive 4. Because I see an x squared here at the end, in order for me to solve this, I'm going to have to factor that polynomial. So I'm going to try to get everything onto one side so that I can factor it. Now, since x squared is already positive on the right side here, I'm going to leave x squared as is. So I'm going to go ahead and just drop this one down. So I have negative 2x and negative 2x, which would be negative 4x. And if I subtract this x over to the other side, that's just going to be another negative x. So that's negative 5 now. So that takes care of all those x's. Okay, and then last would be to take that 18 and move it over by subtracting it. So 4 minus 18 would be negative 14. So that takes care of your numbers. Equals 0. Now let's think about how we can factor this. What are two numbers that multiply to a negative 14 and add to a negative 5? Good. Negative 7, positive 2. So if I set these both equal to 0, I'm going to get positive 7 and I'm going to get negative 2. Okay, now I'm getting two values here for x, so I should probably go back and check them, make sure that they both work, because if one of them or if both of them didn't work, if they don't balance out in my equation that they gave me, then I have to cross one out, because that's that extraneous solution. We've talked about that in the past. If something doesn't pan out, when you go back to plug it in, you have to get rid of it because it's a bad solution. All right, so let's test 7 first. What would be 7 plus 18? 25. And what would be the square root of 25? 5. And then if I do on the right side, what would be 7 minus 2? 5. So 7 is a good solution. Okay, let's test negative 2. What would be negative 2 plus 18? And what's the square root of 16? 4. Okay, so I need a 4 to show up here. What would be negative 2 minus 2? Is it 4? No, it's negative 4, because negative 2 minus 2 would get you more negative. 4 and negative 4 are not the same thing. Would you agree with me? Okay, $4 and negative $4 are not the same. So I cannot take negative 2, so I'm going to cross it off. It's not a good solution. Okay, let's take a look at 7. How they have it written is a little bit different because they don't have the root sign, but they have it raised to the 1/3. We've talked about this in that last section, though, that if it was the 1/3 power, that's the same thing as the cubed root of that quantity. They just don't have it written with a root sign. Now, you can rewrite it with a root sign if you would like, or if you know that 1/3 means that it's the third root, you can go ahead and just raise both of these quantities to the 3rd power. Because it's going to do the same thing. If I take 1/3 times 3, because those are my exponents, that's just going to become a 1, and so they go away. And so that quantity x plus 3 just drops down. Okay, what would be 4 to the 3rd power? 64. So the last thing I need to do here is subtract 3. And I'm going to get 61. Okay, you guys try number 8. Number 8 is similar to number 5 was, if you need something to kind of reference back to. So I would have started by squaring both sides. Since it's raised to the 1/2, that would be the square root. Remember, like we did on 5, when I had a 5 on that one that I had to square. This one is a 3. Okay, this 2 goes to the x plus 6, and it goes to the 3 that's sitting up front. So 3 squared is 9. And then I'm taking that times the x plus 6, because that 1/2 power is gone now. And then equals 9 squared would be 81. So I'm going to distribute 9 times x, 9 times 6. So that would be 9x plus what?
54.
Good. 54 equals 81. What do I do next?
Subtract 54.
Yep. So now I have 9x equals 27. So what are we getting for an answer here when I divide by 9?
3.
Good. X equals 3. For number 9, what I would do first before you guys jump to squaring it is get the 9 and the 7 on the same side. So how would I move the 7 over to the 9? Subtract it. So I'm going to write minus 7. So I'm actually going to rewrite this so that it says the square root of 5x equals 2. Okay, now finish it. Square both sides and solve it. It's going to make it a lot easier. So when you square it, you should have gotten 5x equals a 4. You have to divide by 5. You're going to get a fraction here. It's just going to be 4 over 5, or 4/5. All right, so I'm going to give you guys a couple minutes to try to do 10 and 11. And I'm just going to tell you guys for 11, I would move that 3 over first. So I would rewrite 11 like this. Square root of 2x plus 14 equals x plus 3. Then try to get rid of that square root sign. So I'm going to give you guys a couple minutes here to try to do 10 and 11. So for number 10, what power should we be raising both sides to? Good, 3. So on the left side, just the x plus 6 should come down. On the right side, you have to do 2 to the third power, and then you have that x minus 1. What is 2 to the third power?
8.
Good, 8. And then that's going to be times your quantity x minus 1. Okay, and then we're going to distribute on the right side. So we have x plus 6 equals 8x minus 1. And then we just need to combine like terms here. So if I combine my x's and my numbers, what I would do is subtract x from 8x, which would leave me with 7. Then I would add 1 to that 6, and that would give me 7. Yeah, what am I missing? Oh, minus 8, yeah. This should be an 8. So then when I add 8 to 6, I get 14. And then I divide by 7. So I get x equals 2. Okay, for 11, after I rewrote it, you guys should have squared both sides. Okay, and this one is similar to how number 6 was at the top of this page. When you have a quantity like that squared, remember it's 2 of them. It's x plus 3 times x plus 3. So you're going to have to FOIL that. Okay, now on the right side, or I'm sorry, on the left side, everything just comes out of the square root sign. So it's just 2x plus 14. Okay, and then we have x plus 3 over here. So that becomes x squared plus a 6x plus a 9. So we're going to have to probably factor this one like we did 6 because we're going to have this x squared happen. So I'm going to rewrite it so that it's all on the same side. So I'm going to leave x squared where it is because that's positive right now. I'm going to subtract my 2x from the left side over from the 6x. That's going to leave me with 4. And then I'm going to take 9 minus 14. And that's going to be negative 5. Okay, so can you guys tell me what two numbers would multiply to a negative 5, add to a 4? Good, so positive 5, negative 1. So then when I set those equal to 0, my options are to have a negative 5 or to have a positive 1. So remember now we got to test this here. And you can either go back to the very original equation or you can go back to the one that we rewrote before we started solving it. So if I test negative 5 here, 2 times negative 5 would be negative 10. Plus 14 would leave me with a positive 4. And the square root of 4 is 2. 2 minus 3 would be negative 1. That does not equal negative 5. So if I evaluate the right side here, I get a negative 1 equals negative 5, which is not true. So I can't keep negative 5. If I go and I test the positive 1, 2 times 1 would be 2. Plus 14 is 16, and the square root of 16 is a 4, minus 3 is a 1, and then equals 1. So this is a good answer.